So in our last class, we started working with the standard form of the equation of a circle. So basically, we worked with the format where we had the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. And the nicest thing about that format is that it tells us what the center and the radius of the circle are based off how it's written in this format here. So the values for h and k represent the coordinates for our center point. And then if we take the value for r, we would get the length of our radius for our circle. So this is a very nice format to work with. And so we looked at, given different points on a circle, how we can use those points to write our equation. If someone were to go ahead and take the time to do all the algebra that, our algebra teachers always said, write these guys in simplest form, and that would mean we would get rid of all of those parentheses. If we were to take the time to FOIL those guys out and then combine like terms, we can create what's known as a general equation for a circle. And in our general equation for a circle, what's going to happen is we would get just x squared plus y squared if we were to FOIL out those parentheses. And then we would have, when we FOIL this through, some number times x. So we're going to call that ax. And then in here, if we were to FOIL this out, we would get some number times y. So we're going to say plus by. And then we would have a whole bunch of constants. We would have this last number multiplied by itself and this last number multiplied by itself and whatever the radius was multiplied by itself. And so if we took all of those numbers and combined them into a single number, we would get this extra constant. And so when we're working with our standard equation, our general equation for a circle, this is what the format would look like. The drawback to this format is it doesn't really give me any of my characteristics. So our goal is going to be, how can we take it from this format and shift it so we get back to that format, because we really like that standard form. So we're going to kind of just do a little bit of thinking here, and we're going to try to think about how can we do that? How can we take it from that format? So first, let's look at what are the benefits of having our equation in this format. So you found a treasure map from some mathematically inclined pirate. How lucky are we? And this super genius pirate thought he could hide his key and his treasure chest by using some math equations here. So he superimposed a coordinate plane on a map and told us, according to the clues, that the key is located at the center of this circle. So if we think about our standard form, we know this is x minus h. Well, that number 7 then would be the coordinate of my center, the x coordinate there. And this would be y plus 7. Now my format is supposed to be y minus k, so I would have to have a double negative there, so we would get y minus negative 5. And so, unless the pirate's lying to me, the key should be located at the point 7, negative 5 on this map. Now, he tried to make it a little bit trickier for us to solve this problem here. And he said, well, the treasure chest, and that's important because that's where we want the good stuff that's inside that chest. It's at the center of the circle defined by this. So now he went ahead and, after he had his lovely equation, FOILed it all out and left it in this crazy format. And looking at this, we can't easily identify the center of the circle, so we would have a hard time finding that treasure chest. So what we're going to do is try to think about what algebra skills can we use to take it from this simplified format where there are no parentheses and bring it back to this format, which we see parentheses, and we see these guys are perfect squares. So what we really want to do is think about how can we complete the squares so that we can factor those guys and get through that. So this is what we're going to focus in on today. So all that work we did on Thursday's class where we looked at completing the square, that's going to come in handy for us. All right, so this is my pirate's equation, and we're going to go ahead and write it in standard form so that we can find our center and therefore get our treasure and be happy people. It's really a 3-step process that we're going to do. The first thing we're going to do is group together our x terms. So they're already put together nicely for me. So I would put my x squared and my 4x. And if my goal is to factor this so that in my circle formula I have that quantity of x plus something squared, well, I'm going to complete the square so that this would be factorable into that format. And then I'm going to do the same thing for my y. So I want to put my y squared and my y terms together. And I'm going to complete that square. So again, that guy would also factor into a y plus or minus something quantity squared. And then we put the constant over to the right-hand side. So that negative 20 is just going to hang out there. Now, as we go to complete the square, remember, we're working with equations. So whatever I do to one side, I have to go ahead and do to the other side. So if I'm going to add some number here, I'm going to have to balance my equation and add that same number. And same thing as I'm completing this square, if I'm adding a number here to complete that square, I'm going to have to add a number over there. So we want to make sure we're keeping our equation balanced. So remember, the process for completing the square is pretty straightforward. You identify your b value, which is always going to be the number in front of your x term for this first group. So my b value would be 4. And then we chop that number in half. So half of 4 would be 2. And then we square it. So 2 squared would be 4. And that's what we're going to add here to complete my square. And then to balance my equation, I'm going to plop a plus 4 onto the other side as well. All right, so now if I look at this part of my equation, it's now factorable, and I can write this as the quantity of x plus 2 squared. So it's looking like a standard form now. All right, so that we got through taking care of our x's. Now we want to do the same thing with our y's. So this time we're going to go and find that y term. Take the number in front of that, and that's going to be our new b. So for this one here, b would be 10. Half of 10 would be 5, so we're going to take 5 and square it. That's going to give me 25. So we're going to add 25 to complete the square for our y's, and then balance our equation and add 25 over there as well. And so now I've completed the square. This is a perfect trinomial square, so I can go ahead and factor this now. So this would be y plus 5 squared, because 5 times 5 would make 25, and 5 plus 5 would make 10. And then I just have to clean up this math here. So if I had negative 20 plus 4 plus 25, this would just simplify to be positive 9. And so now if I'm thinking about my treasure chest, I can now figure out, hey, the treasure chest is located at the center of this circle, and now I can see there's my h and my k values. So my center would be at negative 2, remember, because it's supposed to be x minus h. So it would have to be x minus negative 2, and over here this would have to be y minus negative 5. So my center would be at negative 2, negative 5, and that's where my treasure would be buried. And then while we're working with this, the question also here asked me to find the radius of my circle. So the other great thing about this standard form is that the number all by itself on the right side of our equal sign, that's our radius value squared. And so if I want to know the length of my radius, I just have to undo that squaring. So we undo a square by taking the square root. And so my radius would be 3. So as we're going through, the hardest thing is going to be to rearrange that equation. But once you rearrange it, we're going to be able to complete the square. We're going to have to do it twice. We're going to do completing the square for our x's, complete the square for our y terms, and then make sure we're balancing our equations. So we might have to add 2 numbers if we had to complete 2 squares to solve the problem. All right. So now that we've gone through one example together, I want you to go ahead and try this one on your own. So go ahead, pause the video, take a minute, rearrange that equation, complete the square, and see if you can identify the center and radius of this circle here. All right, let's see how you guys did. Welcome back. So again, my first step is always going to be to put my x squared and my x term together. So right now they're not together, so I'm going to just use properties of equality. I know that, addition and subtraction right here, these guys are going to be commutative. So I can take that x squared minus that 8x, and I can shuffle them and put them together since they're already on the same side of my equal sign. And I'm going to put that blank there so I can complete the square on my x's. Then I'm going to go and group my y's together. So here's my y squared already on the left side, but a little bit of a problem here because the 12y is on the wrong side of the equation. So I'm going to have to use a property of equality to move it over and join the left side. So I would have to subtract 12y from both sides, which would make minus 12y on the left side of my equation. And now I brought everybody to the left that I want. And remember, our numbers always stay by themselves to the right. So that -7 is going to stay put. And we will complete the square and balance our equations. Half of this guy right here would be my first b, so half of -8 would be -4. -4 squared would be +16. So I'm going to add 16 to both sides. And just be careful when we factor this because this is a -8. As I factor this and I find numbers that multiply to make 16 but add to give me -8, they would both be -4. So this would factor as x minus 4 squared. All right, moving along to our y's. Half of -12 would be -6. Squaring that would be +36. Balancing our equation, putting that 36 on both sides. Now I can factor this as the quantity of y minus 6 squared. And if I add up all of my numbers on the right-hand side, this would work out to be 45. All right, so that's my standard form. So that's the first thing they asked me to find. So check that off our list. Then they asked me to identify my center. My center point would just be at the coordinates here, h and k. So x minus h, so h would be 4. Y minus k, k would be 6. My center is that ordered pair for 6. And again, that number there is our value for r squared. So I have to take the square root to solve for r. So depending on how the question looks, we could say r is the square root of 45. It's not a perfect square, so I can't simplify that. So I would use my calculator and I could get an approximate value and say it's approximately 6.71. I think that's the right answer. Yeah, that's our right answer for that. And then I could also use our techniques for simplifying radicals, where I break up the square root of 45 as a product of a perfect square. And the largest perfect square that divides into 45 would be 9. So I could break this up as radical 9 times radical 5, and then simplify that perfect square to be 3 radical 5. So that's my exact value in simplified form, and that's an approximate value. So in terms of working through the problems, the only way these get more and more challenging is depending on how these guys are shuffled up and how many x's and y's you have to move around. But the process is always going to be the same. Put your x squared and your x together and complete the square. Put your y squared and your y term together and complete the square. Keep the number all by itself and then balance your equation. And then you'll be able to factor those perfect trinomial squares and add up those numbers to get your value for r squared. All right, so those were the examples we worked on in class, and you'll have some practice with that on your homework. The last thing we're going to look at today is how we use the standard form to solve some problems. Because I don't want you to think that the standard form is not good. It has its time to shine, but the majority of questions are really going to be solved by this lovely standard form. But our general equation does have its moment of glory where we look at it and we can actually use it to solve some problems. And its moment of glory is when we're given 3 points on a circle. And so if I have 3 points on my circle, I could try to put them into my standard form, but then I create this big quadratic mess that I don't want to have to deal with. So this is where general equations come in and steal the show because they're going to make our life so much easier. So in my general equation, I have 3 unknowns, the big A, the big B, and the big C. And if you remember when we're solving systems, for however many unknowns we have, that's how many equations we want to write. So if I have 3 unknowns, I'm going to need to write 3 equations. And those 3 equations are going to come from the 3 points that our circle passes through. And we just need to remember that anytime I tell you a circle passes through a point or a circle contains a point, that those are in my equation the values for x and y. So each of these points can be substituted into our formula in place of x and y. And so what we're going to do is plug in each one and write 3 separate equations. So let's start with that first point, 8, 2. So what I'm going to do is run through my general equation, and I'm going to replace all of my x's with 8, all of my y's with 2, and then I'll have a beautiful equation that I can work with. So this would become 8 squared plus 2 squared. Instead of a times 8, I'm going to write this as 8a. We usually write our number in front of our variable. Same thing here, instead of b times 2, I'm going to write that as 2b, because again, we like the number in front of our variable. And then we have our plus c equals 0. I'm going to now just clean this guy up so that it's in the format that we can actually use to solve a system pretty straightforward. So 8 squared is 64. 2 squared is 4. If I add those up, they're going to be 68. And what I'm going to do is take this 68 and subtract it over to the other side of my equal sign so that I get only the a's, b's, and c's on the left and the numbers on the right. So I'm going to get 8a plus 2b plus c equals negative 68. And there's my first equation. So 1 down, 2 to go. So I'm going to repeat the process for the other 2 points. I'm going to put 1, 9 in for x and y, clean up the equation into that a plus b plus c format, and then do the same thing with 1, 1. So we're going to get 1 squared plus 9 squared plus 1a plus 9b plus c equals 0. 1 squared is 1, 9 squared is 81, 1 plus 81 is 82. So we're going to get a plus 9b plus c equals negative 82 when we subtract it over to the other side. So there's my second equation, and then 1, 1 for my last one. I'm going to get 1 squared plus 1 squared plus 1a plus 1b plus c equals 0. 1 squared is 1. 1 plus 1 is 2. Booting that over to the other side, we get a plus b plus c equals negative 2. Now, we've created this lovely system of equations, 3 equations with 3 unknowns. You could solve this system by hand if you really wanted to using the elimination method, but we're going to use matrices because why not? It's a lot faster. And these are already written in that nice format so that I can actually write them in a matrix. So I'm going to make my coefficients matrix, taking the numbers in front of A, B, and C. And that would go into my calculator as matrix A. Then we take the inverse of that, and then we multiply it by our constants matrix, which is what everything is equal to, and that would go into my calculator as matrix B. And so you would punch those into your calculator, do inverse A times B, get those values, and your calculator is going to spit out a 3x1 matrix where you get negative 8, negative 10, and positive 16. And again, the great thing is that however our variables went into our equation, that's how the calculator spits them out into that final matrix. So we now know that my variables went A, B, C. So this top value is my value for big A. This middle number is my value for big B. And this last one is my number for big C. So now I have all the clues I need to write my general equation. I'm going to go back into that format and replace now A, B, and C with the values we just found by solving that system. So our answer would be x squared plus y squared. Since A was negative 8, I'm going to write this as minus 8x instead of a plus negative. And then by, b was negative 10, so I'm going to write that as minus 10y. And my c was positive 16, so I'm going to put on a plus 16 equals 0, and that's my general equation. And depending on what the question wanted me to do, if they wanted me to now find my center and or my radius, I would then complete the square and write it in standard form and do what we did in those first 2 examples. All right. So basically, we're just looking at taking an equation from general form and either writing it in standard form by completing the square, or using our general equation to write 3 equations. So we create a system, and then we can use that system of equations to go ahead and find the general equation. And then if we had to, we can convert it over to standard form. All right, so homework is linked in the last slide of our presentation. It just had 10 practice problems for you to do. And if you have questions, let me know.